If we're given a set of data points, there are multiple different ways to define what's known as the center. And each of those definitions has a different measure of center. So the measures of center are going to be different ways to define and look at the center of a data set. The three most common, and the ones I will consider, are the mean, the median, and the mode. First, let's look at the mean, also known as the average or the expected value. We denote the mean by the symbol x bar, so this is x with a line over it and is written as x bar. The actual mathematical formula looks at this. The top of this fraction says add up all of the data values, and the bottom says divide by n. This symbol here, this is the capital letter sigma, and it just means to add up a bunch of things. So in this case, add up the data values. N is the number of observations, so we're going to divide by the number of things. As an example, let's suppose we have the data points 2, 3, 5, 7, 7. For the mean, we're going to add up all of these values, 2 plus 3 plus 5 plus 7 plus 7. And we're going to divide by the number of things. And if we count, we have 5 things, 2, 3, 5, 7, and 7. When we do this, we get 24 over 5, or 4.8. The mean is very commonly used because it's found by using all of the values of the data. In addition, it does vary less than the mean and the mode between different samples. It's also used in other statistics such as the variance, which will be discussed in a later video. It is unique and it may or may not be one of the data values. In this case, it was not. However, the mean is affected by extremely high or low values, known as outliers. And as a result, it may not be the appropriate measure of center to use in these situations. The second measure of center is the median, and this is the middle data value. To find the median, the first step is to order the data, and then we need to find the middle. And the middle is going to vary depending on if there's an odd or an even number of data values. As an example, let's consider the data set 2, 3, 5, 7, 7, just like before. And in this case, we can see that 5 is the middle. There are 2 numbers on the left and 2 numbers on the right. And that puts 5 in the middle, so our median here is 5. On the other hand, if I were to add an additional data value to this set, let's say 9, we now have an even number of data values. In this time, you can see that there's not a number in the middle. I can draw this vertical line here that would put 3 on the left and 3 on the right. So in this case, we take the 2 numbers that are the closest to the middle, 5 and 7, and we find the number halfway between them. Halfway between 5 and 7 is 6. So in this case, the median is 6. The median is used whenever it's necessary to find out whether the data falls into the upper half or the lower half of the distribution. It's also affected far less than the mean by extremely high or extremely low values. As a result, we often use the median over the mean when we have outliers present in our data set. Our third measure of center is the mode. The mode is the number that occurs the most often. A data set can have one mode, which is known as unimodal. It can have 2 modes, known as bimodal. It can have multiple modes, which is known as multimodal. And it is even possible that a dataset has no mode if no value occurs more than once. Let's return to our dataset 23577. In this case, we can see that our mode is 7, since the data value 7 occurs more often than any other value. In fact, we have 2 7s, whereas the rest of the data values we only have 1 of. The mode is used when the most typical case is desired, and it's also the easiest measure of center to compute. In addition, it can be used when the data is categorical or numerical, unlike the median and the mean, which have to have numerical data. However, the mode is not always unique, and it may not even exist, so oftentimes it is not an ideal measure of center. Having the histogram of a data set can also give us information about the mean, the median, and the mode. If the histogram is symmetric, like this one here, then the mean, the median, and the mode will all occur directly at the center, in the middle of the tallest bar, as we see here. If the distribution is skewed, however, the values will be affected. The mode will always occur at the tallest bar, as we see here. The mode occurring at this tallest peak right here in the center. However, since the mean is more affected by the outliers that we see in the tail, the mean will be pulled further along the tail than the median. So in this case, in this left skewed distribution, we see the mean further to the left than the median, and then the mode at the tallest peak.
If you would like to see Professor Pierce make more videos like this one, you can support her on Patreon in the link below. Any and all support means a lot to her. It allows her not only to make more videos, but it also allows her to campaign for free and accessible online education to conferences and other universities. Thank you for watching, and remember, math is for everyone.